My voice is clear to you all? Okay, fine. Let me present my screen to you all. Is it visible? Okay, so see, in last lecture, I have discussed about SHA 512. I think up to this point, I have discussed, right? So let's again quickly go through it so you can understand the later concept. So in last class, what I have discussed, how the see, all of you know the functionality of what is the use of hash function, right? All of you know that. So in SHA 512, what happened? So here you can say that there is a message. It is divided into block, and each block of what 1024 bits. All of you know that. So here you can say that it's a multiple of 1024 bits, right? Now in that what I have explained, so this the initial some initial hash value, initial some digest is there, right? So here the initial digest, it is mix. The digest is initialized with some predefined value of 512 bits, and then what happened? The algorithm mixes this value with the first block of the message, right? The first block of the message, and then what happened? It create a intermediate digest, and then again what happened? Again this intermediate digest is mixed with what? The second block of the message, and then again you get the second intermediate digest, and finally the n minus one month digest is mixed with what? It mixed with the nth block to create the nth digest, right? So in this way the message digest creation is done, right? All of you know up to this. Now in that, see, some of the students have asked what is this block, everything that I have explained. So what is comparison function and how we are achieving this 512 bits, right? So here in that, first of all, I will explain you what is this block. So in particular, you can say that the SHA 512 that is operate on a word, right? So it is a word oriented, and so if I'm talking about this particular block one, so this block one that is 1024 bits. So here you can say that in each block total 16 words, and and 16 words each of 64 bit, and that's why you can say that it is 1024 bits. Okay, and then finally see whatever the message digest that you are getting, that is 512 bits. So here you can say that 8 words and each of 64 bits. So in this way you are getting 512 bits, right? So this thing that I have discussed, right? So you have to remember, so initial some predefined value is there, some message digest is there, and it is mixed with what the first block, and based on that you are getting this 512 bits. So now how we are achieving this 512 bits? So in that see, in your class I have discussed, so for that total, how many total 79 rounds are there, and after applying this 79 rounds, finally you are getting the 512 bits, right? So how we are achieving that thing? So let's see this figure so you can understand. Just wait. Yes, this is the figure. Right. So in that, what I have explained, suppose I can say, suppose this is my initial digest. Okay. So now how I am achieving this first intermediate digest? So for that, this figure that I have explained, let's say assume these are initial digest, and all of you know that it is what? It is a 512 bits. It's a 8 word and each of 64 bits. Okay. So now what happened? So total 70 now. This is around 0. After round 0, see once here in this first round 0 is there, then after you are getting some digest, then similarly round 1, round 2, 3 and so on. So up to total what? 0 to 79 now 9 rounds are there, and at the end of the round 79 you are getting some digest, right? You are getting the digest of 512 bits. Now what happened? So here in this case, once you are getting after 79, once you are getting this digest, then what happened? So whatever the initial digest, means see here this one, whatever the initial digest 512 bits are there, and after this 79 I am getting this digest. So now what happened? So now this A And then which sign here, what is the meaning of the meaning of it, that is the addition modulo 2 raised to 64. So now what happened, a plus a, addition modulo 2 raised to 64 is performed, and then finally you get a. Then b plus b, addition modulo 2 raised to 64, and then you get b. So in this way, after performing this, you are getting this digest, right? And what is the meaning, what it digest, this this digest, it means that these are 512 bits that you are getting. So again I repeat, initially let's say if I want to find this 512 bits, so what happened, initial some digest is there, then after what happened, so in this compression function you can say that total round 0 to round 79, this many rounds are performed. Once these many rounds are performed, then after in between after the round 79, this addition is performed, and finally whatever the digest that you are getting, this is your 512 bits, that means the first intermediate digest. And again I think the one of the student have asked me a question, what is this block 1? So all of you know that, see, when you observe this figure, so in this case, see, this W0 is there, so that means, see, total, all of you know that total how many words are there. So in block that is 1024 bits, means total 16 words and each of 64 bits, right? So now when you're talking about round 0 to round 79, so we have a 16 word. So for round 0, W0 word is used. For round 1, the W1 word is used. Round 2, W2 word is used. In this way, all the words are used. And all of you know that, right? So suppose, let's say I'm assuming, suppose I want to find this 512, means I want to find second intermediate digest. So in that case, what is your initial value? So this first intermediate digest that you have to take on here. And again, the round 0 to round 79 are performed. This operation is performed, and finally, whatever the digest that you are getting, that is your second intermediate digest. So up to this clear, everyone? Yes or no? Is it clear to you all? Please reply. Hello? Can you hear me? Okay, fine. So in this way it works, right? That I have explained now. Then after, see, this is the whole process that I have explained, right? But see, now again the question arises your mind that I have explained, that is, see, once I am performing the round 0, then after the round 0, how I am getting this digest, right? So for that, what you have to do, so let's say assume, see here in this figure, so this is my initial digest. Now when I'm applying the round 0, how I'm getting this digest? So now see the figure. So now this is my initial digest, and after the round 0, I am getting this one. Okay, so here for that, which are the inputs ki and wi? So see the figure. So the word, and these are constant. So later I will explain you so you can understand. So the word for round 0, W0 word is used, and the constant, that is K0, is used. So this is my input, and at the end of round 0, what I am getting, the 512 bit, means the this digest that I am getting, right? So now how I am achieving this? So you have to remember, see, this all the A is copied to B is copied to C is copied to D, so E to F to G, and G to H. So that means the 6 buffers are the exact copy of the one of the buffer in the previous round. But right now again, what about this A and H? What about this A and E, right? So how to find this value? So for that, how to achieve this X and Y? So for that, I've explained this thing. So you have to remember this figure, right? So in that, let's say what happened, for that I have explained how to find the majority, how to find the rotate operation, how to find the conditional, right? So actually what happened, first of all, any ABC, any bits are any bit is given to you, right? So first of all, find out the majority ABC, find out the rotate A, and then after what happened in between, you can say that what is this sign, that is the addition modulo 2 raised to 60, addition modulo 2 raised to 64 is performed, and finally here what happened, here again the conditional this operation is performed, rotate operation is performed, and finally here you can say that just wait. Okay, sorry for interrupt. So how to find this x and y? So for that, first of all, what is this majority? So how to find this majority? So for that, I'll explain you this formula, that is a majority of x, y, and z, right? So that is what x and y, x or y and z, x or x and z. So for example, the x is 7, y is e, and z is e. Okay, so based on that, if you are applying this formula, so what you get e, right? So that means if I'm taking this input, so by applying this majority of ABC, I'm getting E over here. Now again the question arises your mind, that is how to find the rotate, how to perform the rotate operation, right? So for rotate also I have explained you this formula, that is see the ROT, the what is the meaning of it? The meaning is the right rotation of argument x by how many bits? 28. And see, this is a fixed formula. So if you want to perform the rotate A, then what is the formula? The right rotation of argument A by 28 bits XOR the right rotation of A by 34 bit XOR the right rotation of A by 29 bits, right? So in this way you have to perform the rotate A. Okay, and once it is applied, so finally whatever the value that you are getting, again you have to perform what? Addition modulo 2 raised to 64, and then finally again after the 2 raised to 4, whatever you are getting here from this whatever you are getting, and finally you have to perform the 2 raised to addition modulo 2 raised to 64, and you are achieving this x value. Okay, so here in this case, how to do it? So how to, let's say my data is 1011. So how to perform this rotate right in circular manner? So see here, this 1 0 1, and finally the 1 is in what? First position. Now here again you can see that 1 1 0, and then again 1 is in first position, right? 1 1 1 and 0 is in first position. So in this way this rotate right operation is performed. Now again in this table, the conditional operator, right? So what I have explained in for conditional operator. So see here. Up to this, anyone have a doubt? Is it clear to you all? Please reply. Hello. Hello, can you hear me? Okay. Is it clear? Okay, fine. So now what about this conditional? So this is the equation that you have to remember, x and y, XOR not x and z, right? So for example, x is 9, y is e, z equals to f, right? So if you are applying this formula, then finally you are getting e. E is in hexadecimal. So in this way you are achieving this x, and in this way you are getting this x and y value. Okay, so now once it is done, now then after, the next topic is word expansion. Now see, when you observe this figure, so here what happened, see what I have explained. See, again I will explain. So in this figure, observe this figure. So now let's say start with the initial value. Now from initial value, all of you know that total 80 rounds are there, and after the 80 rounds I am getting 512 bits, right? So now see here what happened. So all of you know that here in that see words are used, and from where words are taking, these are from block 1, right? It's a word oriented, so from this the word are taking. But all of you know that here when I am talking about the first intermediate passage digest, so at that time block 1 is used, right? But here total how many rounds are there? Total round 0 to round 79, total 80 rounds are there, and we have how many words? Please write down in the chat window. Total how many words are there in a one block? Please write down in your chat window so I can understand. total 16 words are there, right? So now what we have to do, so that means here you can say that total 16 words are there. So where w0 is used for round 0, w1 is used for round 1, w2 is used for round 2. So now see, once after the w16, how I am achieving the w17, right? So for that, what you have to do, you have to perform the word expansion. You have to perform the word expansion. So now how to perform the word expansion? So for that, see this figure so you can understand. So now see, here I have written a block is made of 1024 bits or 64 bits. Now we need 80 words in a processing phase. So the 16 word block needs to be expanded to 80 words from W0 to W79, right? So all of you know that. So here in this case, what happened? How the word expansion in SHA 512 is performed. So total, the block of, see, the particular block of is of 16 words, right? That is 1024 bits. Now from that, how I am getting the another word? Let's say I'm talking about WI. Let's say the value of I is 17 or the value of I is 18 or something. Okay. So now, so for that, this formula you have to perform WI minus 16 XOR. See here, I have written this formula. If you want to find a particular word, then that is what WI minus 16. Okay, XOR rotate shifts 187. What is this 187? Later I will explain you so you can understand. WI minus 15. See, this equation is fixed. XOR the rotate shift 1961 6. 1961 6 WI minus 2. Okay, XOR WI minus 7. WI minus 7. So in this way you can find the word. In this way you can find the word. Okay. Now, what is this? First of all, I will tell you what is this rotate shift 187. So this is the formula that you have to see. This is the formula for, see, you have a 16 word total in a particular block. You have a 16 word. Now I want to, because but the total 79 rounds are there, right? So now how many? So the word expansion I have to produce. So for that, if I want to find, let's say W17, then what I have to do? For that, I have to use this formula, and with the help of this formula I am getting the W17 word, let's say. Okay, now for in this equation, what is this ROT shift? So the ROT shift, rotate shift, LMN, right? So this represent L, this represent M, and this represent N. Okay, so now, and this X. So now how to find it? So the meaning of the rotate shift, that is rotate right L. So what is the ROT? See here, if I'm writing L means this number of bits. So all of you know that the right rotation of argument X by how many bits? I can say that L bits. Right rotation of X by how many bits? M bits. And here, right, now all of you know that how to perform the right rotation, right? That already that I have explained. And now this is a new for you, that is SHLN. So what is the meaning of it? The meaning of it, that is the shift left of the argument X by how many bits? By I bits, and the padding the left by zeros, right? So now how we are achieving that? So one of the example that I have written, suppose let's say my input is 1011. So how to perform this? Suppose let's say the 4 times, let's say I is 4. So that means the 4 times I have to perform the shift left, right? So how to do it? So shift left, so that means 0, 1. How to perform the shift left? So here I can say that how to shift left by 1 bit. Okay, shift left by 1 bit. So that means 0, 1, 1, and finally what you have to do? Padding the left by zeros you have to pad. Again 1, 1, 0, and then the last one is paired with what? 0. Then again 1, 0, 0, and the last one is paired with 0. Again I am performing, that is 0, 0, 0, and the last one is 0. So up to this, clear everyone? How it works? Is it fine? Please reply. See, I want the answer from everyone. So Priyank, I will explain you so you can understand. Fine? Okay. So up to this, clear everyone? Yes or no? Okay, fine. Okay, Priyank, your question is I want to find for W16 because we have a W0 to W15. Here I have written 16, but see it is W15. Okay, so now if I want to find W16, so I have to put the value in this formula. So W16 that is equals to W16 minus 16 that is W0 XOR rotate shift 187 W16 minus 15 that is W1 XOR 6 W16 minus 7 XOR rotate shift 19. These are the bits and 16 minus 2 that is W14. Now Priyank, is it clear? Priyank, can you hear me? Hello. Is it fine everyone? Right. So in this way you can get the word. Now see, here one thing that I have written, how the W60 word is made. See, the same thing that I have written. If I want to find for W60, let's say. So, right, so W60 means what is my formula? 60 minus 16. So what I am getting here, W44 XOR, right? Rotate, here I have rotate shift, that for instead of that I have written RS. Okay, then 187 W. What is the value of I? I that is 60 minus 15. 60 minus 15 that is 45. Okay, XOR. What I have to write here? See W 60 minus 7 that is you can say 53. Okay, XOR. XOR rotate shift 1916 61 6 and 60 minus 2 that is W58. Right. So is it fine everyone? Is it clear to you all? So now see this figure everyone. So up till now what I have explained. See now understand this figure. So now you have a whole clear idea. So now see. Basically my purpose is what is my purpose? My purpose is, see, the message is given to you, how I am getting the message digest, right? So for that, what we have done, some initial value that we have taken, let's say the initial value is this. Now, then after what happened, the round 0 to round 79 are performed. And then after I have explained you that after the round 79, whatever I am getting, addition modulo 64 is done. And whatever the digest that final I am getting, that is what, so that is my first intermediate digest, right? All of you know that. Now then after what I have explained here in this figure, so now see your question is what is the use of this block 1? So now see this is the initial value plus the block 1, it mixes with this function. So now for that what I have explained, the W0 to W79, right, total, because in each and every round the words are used. But see in a particular, but see here in when I'm taking the initial value, so here in block number 1 only 16 words are there, right? But see in each and round total 79 rounds are there. So for that how many W0 to W79 words are required? So for that what I have done everyone, so for that see the word expansion that I have performed, right? And then already that I have explained, that is if you want to find the W60 word, then this formula you have to use, and with the help of that you are getting that particular word. So in this way you are getting all these words, right? And also I have explained this thing everyone, that is the initial value is given to you, and after the round 0 how you are achieving this digest. So all of you that I have explained, some of the 6 bits are copied, and for that the 2 bits are remaining. So in that how to calculate that x and y also that I have discussed, right? So now I think all of you up to this clear, yes or no? Is it clear to you all? Is it fine? Right? So the whole flow is clear to you all. Now again the question is your mind, that is, see, now I have a word W0 to W16. Now you know how to get the up to W79, how to find this W79 value, right? All of you know that. Now again the question that is, now see how to find this constant value, how to find this K0 to K79 value, right? So now that I will explain you next. Okay. So how to find the constant in a SHA 512? So the see total there are how many 80 constants are there, K0 to K79 in a hexadecimal format, right? So these values are calculated from the first 80 prime number. So that is, let's say I'm starting from 2 comma 3 comma up to the last 80 prime number, that is 409. Okay, I have not written all that 80 prime numbers, but if you want to find the 80 constant, so for that what you have to do, the first 80 prime number that you have to take. Okay, now then after what you have to do, so for ki, if you want to find the ki, for ki take the I plus 1th prime. Okay, that you have to take, and then see these are the steps that you have to perform, and with the help of that you are getting the constant value. Now once you get after that what you have to do, find the cubic root of the corresponding prime number. See, let's say directly I will show you the example so you can understand. Suppose the 80th prime is 409. Okay, so let's say if I want to find this constant value, then what I have to do, so the 80th prime, the because 80th prime, that is see, because see why I am doing this, because if I want to find this 79, right, because I'm because it is start from 0, and that's why I can say that for ki you have to take what, I plus 1 prime, right? All of you know that. So for 80th prime it is 409. Okay, so for that what you have to do, find the cubic root of the corresponding prime number. So 409 you have to find the cubic root. So I'm getting this something, this type of value that I am getting. Now once you find the cubic root, then whatever the value that you are getting, what you have to do, converting this number to a binary with only 64 bits in the fractional part. So convert number to a binary with only 64 bits in a fractional part. So now once, so you have to convert it into the binary, and after that what you have to do, only what the 64 bits in the fractional part that you have to take. Okay, then after that what you have to do, so after that whatever the answer that you are getting, then convert to hexadecimal, right? So now see here, only this part you have to consider. So here what I am getting here, so see this 7, and even you are finding the hexadecimal, so what is this 6, this c, this 4, this 4 1, and so on. So now see, this is a fractional part. So and what after that what you have to do, keep the fractional part as an unsigned integer. So these your what, this is constant. So now see, in your book this material is given to you, I will show you so you can understand. See, when you observe that, see, these are the total 8 constants are there in a SHA 512, this given in your book. And when you see that the last constant, that is 6C44198C. Now see that I have calculated 6C441. Is it clear everyone what I'm trying to say? Is it clear? Hello, can you hear me? Hello, can you hear me? Hello. Okay, fine. So this all about this SHA 512, right? So now this is the one of the function, hash function, right? All of you know that the purpose of the hashing function, that is in input the variable length message is there, and after applying the hash function you are getting the fixed digest, fixed value digest, right? So this is the use of hashing, right? All of you know that, and for that the MD5, Whirlpool, SHA 512, this SHA 512, it's a well-known hash function, right? So that's why that this thing I have discussed. Okay, so this is the one of the hash function. I will not explain you each and every hash function. Okay, so this is the concept that I have covered. Now the next thing that I want to explain, that is, and see, also this is the material from your book SHA 512. So also I will provide you this material, so you can go through both my material as well as the this PDF also. Okay, so I will share this material. In material, some other concepts are also given, right? You have to go through just SHA 512. The other material like Whirlpool is also given here, so I will not explain you that thing. Okay, but I will provide you so you can get all the information. I will provide you whole the PPT. Okay. Now, see, one thing that I want to tell you, that is in second lecture, right? In the very second lecture, I have explained you that how to achieve the message authentication. So in that, just you have to listen. So if there are two party Alice and Bob, so how to achieve the message authentication, right? So in that I have explained you one way, that is what you have to do. Let's say initial some message is there, both the party have a symmetric key, then the message is encrypted with some key, and message along with the encrypted keys, it is send it to the Bob. Right now, what the Bob will do? So Bob perform the decryption with the help of that key, and if the messages are same, then the message are compare, and if the messages are compared, then you can say that the authentication is done, right? So this is the one of the way that I have discussed in second lecture, that I have discussed. In this way you are achieving the message authentication, right? The another way that I have discussed, that is if the message is very long, if the message is very long, then what you have to do? So the other way that I have discussed, that is, let's say my message is very long, then I am using the hashing. Right now, once the hashing is done, then after what I am doing, so encrypt it with the key, and then the message along with this encrypted, this digest, now it is send it to a what? It is send it to a Bob. Now once it is send it to the Bob, so now what the Bob will do? So here you can say that see, with the help of this key, now it is decrypted. So what you are getting, the hash, this digest that you are getting. Now again, what happened? In this message, the hash function is applied. So whatever the HM that you are digest that you are getting, the both the digests are compared. Both the digests are what? Compare, and then finally you can say that, see, if they are compared, that means you can say that the authentication is achieved. Yes or no? See, this thing, concept that I have explained in your class, right? Is it clear up to this that I have explained in second lecture? Yes or no? Please reply, everyone. Right? So this concept that I have explained in your class, right? But see, here what I'm trying to say. So in this scenario, what I have explained, when Allah is sending a message, when Allah is sending a message with Allah is sending message, right, to a Bob. So at that time, what happened? Suppose, let's say, this scenario, I think in second lecture I have discussed, that is, suppose, let's say, I can say that some attacker come. So now what happened? That in this scenario, the attacker cannot do anything, because what happened? The Oscar cannot encrypt this algorithm again, because the Oscar, the let's say attacker is Oscar, because see, both the party have this symmetric key. So my question is, if the attacker come, so attacker cannot encrypt this again, because the attacker, let's say the name is Oscar, is not having this secret key, right? But at that time, what happened? But here I can say that the Bob, the receiver, the receiver can maliciously can cheat the allies in this authentication scheme, right? So this concept that I have discussed in second lecture, right? So now what the Bob will do? So the Bob will receive this message, right? Now Bob what the Bob will do? Bob decrypt it using the decryption algorithm, and based on that, what the Bob will get? The Bob will get the message, right? Once the Bob will get the message, now what happens? So again, Bob encrypt it, because the Bob have this key. So again, Bob encrypt this message, right? And Bob claim that this message is coming from allies, right? And so Bob can force here by changing the message, because there is no way the allies can prove she did not send this message. And that's why, to prevent this type of concept, you can say that we have introduced the concept that is digital signature. So again, I repeat, in this scenario, what happened? The Bob decrypt the message, and once after the decryption, the Bob get the message and again encrypt it by using what key? So when encrypt it, so means Bob modify the message and then claim that this message is coming from allies, but it is not coming from allies, right? So in this way, the Bob maliciously cheat the allies. And so to avoid this type of attack, you can say that to prevent this type of attack, the new concept is introduced, that is a digital signature. That is known as what? Digital signature. So now see, in today's, I will explain you in today's concept. I will explain you in somewhat basic idea I will give you, and later in next class in digital signature I will explain you in detail. Okay. So here I can say that in the case of digital signature, what happened? So this is a message, right? So now the hash function is applied, and now after the hash function is applied, what happened? So the message, now when you apply the hash function, so what you get? The digest. And now what happened? The here the private key of allies is used. The private key of, for encryption, the private key of allies is used, and then the message along with this, now it is sent it to a what? Bob. Now on Bob's side, what happened? On Bob's side, the here you can see that in Bob's side, with the help of the public key of the allies, the decryption is done, right? So when you decrypt it, so what you get here? What you get here? The digest you are getting. Again on this message, the hash function is applied. So you are getting some digest. Now both the digests are compared. Now if it is compare, then I can say that here by using this scheme, right, the allies makes sure that allies says that, right, I have sent this message to a what? Bob, right? But in the previous case, what happened? So in this scenario, you can say that the Bob maliciously cheat the allies, right? So because the both have a key, so what happened? So by using the key, you can say that the Bob can get the message again with the help of key, encrypt it, and then what happened? And then says that this message is coming from allies. But see, in this way, Bob cheat the allies, right? Here in this case, what happened? So whatever the message is there, you can say that first the hashing is applied, and then here the private key of allies is used. And see, the Bob will decrypt only by using the what? Public key of the allies, right? So in this way, what happened? So here when the hash are compared, so that means here the allies can say that, okay, this is my message, right? The allies sure that see, I have sent this message. Okay, so in this way, Bob never cheat the allies. Now, is it clear to you all? Is it fine, everyone? Hello, is it clear? Can you hear me? Hello, can you hear me? Hello. Okay, fine. So now that's why here I can say that what is the goal of this? So it provides the authentication of the message, the digital signature using the private key, non-repudiation, and all of you know that what do you mean by repudiation? Please write down in a chat window. What do you mean by repudiation? Hello, can you hear me? So what do you mean by Chandresh? What do you mean by repudiation? Please write down in your chat window. I think in first lecture, these all terms already you know, everyone. What do you mean by repudiation? Okay, fine. If you don't want to reply, no problem. So now see how non-repudiation. So now see here in this case what happened. The receiver can prove that the message is indeed sent by a sender because the sender has used the in the digital signature. What happened? The receiver can prove that the message is sent by a sender only because the sender has used what? The sender has used the private key for encryption. The sender has used what? The private key for encryption, and that's why you can say that the receiver can prove that the message is sent by sender, right? So this is not the case with Mac. See, this is the concept of Mac. All of you know that. This is the concept of Mac where hash plus symmetric encryption is done, right? So in that, what the problem that already that I have told you. So in the digital signature, you can say that the receiver can prove that the message is sent by sender because the sender has used the private key for encryption. But this is not the case with Mac. In a Mac, what happened? Once the receiver receives the same thing that I have explained. Once the receiver receives the data M, the receiver can modify M to M dash. See this scenario that I have explained. Once the receiver get this message, now what the receiver will do? So decrypt it, and finally the receiver get the message. Right now, once the receiver get the message, what the receiver will do? So here it is written, the receiver can modify M to M dash and encrypt the HM dash by using the symmetric cipher. All of you know that. Where you can say that where this M dash is not equals to M. So that means the M dash is a modified message, right? So now see here, once it get what the receiver will do. So whatever the message, whatever the message the bobs are getting. So now this what original message and this M dash is not matched, right? And that's why here you can say that see the message is what? The message is a modified message. So you can say that, and the receiver claim that the Y is actually received by he, not it is received by what? The sender. So the and sender can't prove that he has sent this message. He has sent EKHM, not EKHM dash, right? In our case. So that means in the case of Mac, the sender can't prove that this message is sent by me, right? But in the case of what? Digital signature, the receiver can prove that the message is sent by sender because the sender has used the private key for encryption. And that's why, so this in Mac, you can say that this is known as a repudiation, and it is possible in a Mac. But in a digital signature, the sender uses the private key to encrypt the data. The receiver can decrypt only using the sender's public key, and receiver can't encrypt as he doesn't have sender's private key, right? Clear everyone what I'm trying to say? So receiver can't cheat in the case of digital signature, and that is known as a what? A repudiation cannot happen. Is it clear everyone? So Mac provides what? Integrity, authentication, and Mac does not provide the doesn't provide the non-repudiation. Repudiation is possible. So is it fine? Is it fine up to this? Hello, can you hear me? Right, so I think all are clear. Now, which are the application of this hash function? So the hash functions are commonly used to create a one-way password file. So operating system using a hash of password file password in the password file. So when user enter a password, its hash is compared against the store hash value, and this will identify the user is authorized or not. So this is the one of the application. What I'm trying to say, where the hash function is used, the operating system uses a hash of password in the password file. When the user enters a password, it hash is compared against the store hash value, right? And this will identify the user is authorized or not. So this is the one of the application of the hash function, right? The hash functions can also be used for intrusion detection and virus detection. So let's say some file is there, hashing is applied, right? And here there is a store. Some storage is there. Now what happened? What is the use? So it can be used to check whether any file has been changed by a virus or not. So later on, what this asset can be used to see whether the file has been modified or not. So here whatever the hashing and here these values are there, both are compared, and see if they are matched, then I can say that see the file is not modified. So this is the another application of the hashing, right? So cryptographic hash function can be used to construct the PRF, that is pseudo random function, and PRNG, that is pseudo random number generator. And the common application of hash based PRF is for the generation of symmetric keys. So these are all information about the hash functions, right? Now there are some terminologies are there, right? So now hash function have some properties, right? So which are the terminology for this hash function? So up to this clear, everyone? Is it clear? Anyone have a doubt? Okay, fine. Now see here, so these are the some properties of the cryptographic hash function. Let's say image, that is y equals to hx. So here I can say that y is the image of x under h. H means hash function, right? So these are the requirement of cryptographic hash function. It should be a pre-image resistance, second pre-image resistance. So these are the requirement of cryptographic hash function. So the first of all, that is pre-image. So here you can say that this property means that, see, first read this property. X is the pre-image of y. X is the pre-image of y under h. So here you can say that it's a one-way pre-image resistant property. Given a x, should be easy to find y, and given a y equals to hx should be difficult to find x. So this is known as a one-wayness or pre-image resistant property of the hash function. So again I repeat, so the first property requirement of cryptography hash function, that is pre-image resistance. So what is the meaning of that? This property means that it should be computationally hard to reverse a hash function. So that means here I can say that for any given hash function, it is computationally infeasible to find y such that hy. So see here, this is the in pre-image what. So here you can say that this is the function y equals to hx. So here I can say that given a x, if x is given, it should be easy to find y, right? So y equals to hx. But here, here I can say that given a y equals to hx, then here it should be very difficult to given a y, then it should be very difficult to find x. So that's why you can say that this is known as a one-wayness or pre-image resistance property of the hash function. Okay, so this is the one-wayness or pre-image resistance property. Now, what about the second pre-image resistance, or you can say that the weak collision resistance? Just wait, everyone. The second pre-image or weak collision resistance. So for any given block X, it is computationally infeasible to find, for any given block, it is computationally infeasible to find y not equals to x such that hy equals to hx. So what this property means, second pre-image resistance. So this property means that So see, first I'm talking about the pre-image. So again, I repeat everyone, the first pre-image resistance says that this property protect against an attacker who only has a hash value and is trying to find the input. Again, I repeat. So this see, all these are the requirement of cryptography hash function, right? You can say that following are the terminology. The first property of the it is desired to the hash function is desired to possess the following property. The first property, that is the pre-image resistance. What this property says, see here you can say that given a x, it is very easy to find y, but given a y, it is very difficult to find x. So this property, with the help of this property, it protects against an attacker who only has a hash value. The attacker who only has a hash value and is trying to find what? And is trying to find the input, right? So this property protects against the attacker. Now, what about the second property, that is second pre-image resistance? So what this property reads? So again, read it: for any given block X, it is computationally infeasible to find y not equals to x such that hy equals to hx. So what this property means? This property says that given an input, given an input and it has value, it should be hard to find, a different value with the same hash, right? If the hash function h for an input x that produces hx, then it should be difficult to find any other input y such that hy equals to hx. Again, I repeat everyone. This property means that given an input and a hash value, it should be hard to find a different input with the same hash, right? If a hash function h for an input x, it produces hx, then it should be very difficult to find any other input value y such that hy equals to hx. Is it clear, everyone? Is it clear what I'm trying to say? This is the property that any hash function that possesses. Is it clear? Can you hear me? Okay, fine. And this is the third property, that is strong collision resistance property. It is computationally infeasible to find any pair xy such that hx equals to hy. So this property means that it should be hard to find two different input of any length that result in a same hash, right? So for a hash function h, it is hard to find any two different input x and y such that hx equals to hy. So this property makes it very difficult for an attacker to find a two input value with the same hash, right? And also, if a hash function is a collision resistance, then it is a second pre-image resistance, right? Because all of you know this property, right? So this thing that you have to keep in mind. So these are the all properties. Now, is there any doubt up to this, everyone? So we have a still last 5 minutes left. So is there any doubt? Please explain. Please tell me. So now see, based on this property, the question can be asked. Same way, like you can say that some constant is given to you, right? Let's say I told you that see, you have to remember this formula, and suppose my question is find out the word W17. Okay, so you have to remember this formula, and based on that you have to calculate. In this way, I will explain you, right? Or let's say or you have to write down the formula, then how to find out the constant. Suppose you have to remember all these 80 prime numbers, right? So now all of you know, suppose let's say I told you that find out the third prime number. Okay, so now for that you have to remember this. You have to first calculate the cubic root, then convert to binary, then convert to hexadecimal, all this concept that you have to remember, and in this way you have to calculate the constant. So in this way the question can be asked in exam, right? Similarly, you have to remember this all formula for majority. I will give you this type of beat, right? So in MCQ, this type of question maybe there for rotate, right? Similarly for conditional. Okay, so these all formulas that you have to remember. So is it clear, everyone? So is it clear to you all? Anyone have a doubt? So up to this property that I have discussed. So in next class, again start with the digital signature, and in that I will explain you one concept, that is RSA DSS. Okay, RSA digital signature scheme, that I will explain you in next class. Okay, fine. Thank you, everyone. Is there any doubt? If you have any doubt, then please write down in the chat window. So is it clear? Hello. Is it clear to you all? Okay, fine. Thank you.